Good morning, folks. This is Mr. Walker coming to you with our next round of notes. We're talking about quadrilaterals on the coordinate plane. Last time we were going over the slope and the distance formula. This time we're going to show you how to put that in action to see if a quadrilateral is a certain type on the coordinate plane. So let's talk about some things. Starting off, the slope and the distance formulas can be used to prove the properties of quadrilaterals on the coordinate plane. So, first thing we got to do, we're going to classify to see if this is a rhombus, a square, a rectangle, a parallelogram, or just a quadrilateral. And we're going to use these points, M, N, O, A, and P. So first thing we're going to want to do, sketch this quadrilateral on the coordinate plane. So we got M going from -2 to 5, N going from 2 to 6, O for -2, and P, O, and -3. Now, after we do that, we have a couple of things that we're going to want to find. We're going to want to name all four of these sides, and we're going to put them right up here in this top part of the table. So we got MN, NO, OP, and PM. After we go through and find these, first let's find these slopes. So if you don't remember how to find the slope, remember we're checking from how we went from one point to the next point. So the top part of our slope, that is our rise, aka our change in y. And that is over our run, which is our change in x. So looking from M to N, that's a nice easy thing. I see I'm going up 1, so that means the top part of this fraction, 1. And I went over 1, 2, 3, 4. So that means that this is 1 over 4. I look at my slope for N to O, I see that it's going down. So that means that top part of this is going to be negative. How much negative? Let's check. I went down 1, 2, 3, 4, 5, 6, 7, 8. And then over 1, 2. So this is down 8 over 2. This could be reduced though. This could be reduced down to -4 over 1. All right. Now that's two of those here. Let's go through and get into the rest of these. We found our first two. That was 1/4, -1 over 4. OP has a slope of 1/4, and PM has also a slope of -4 and 1. After we go through and find these slopes, next thing we got to do, we got to find the distances for all these. So that's going to be involved in doing the distance formula. That is quite a lengthy process, but you got calculators and you got some papers, so you want to go through and do that. As we do those distances, here's what we got. I found that these two shapes here, not these two shapes, these two sides, MN and OP have the same length, 4.1, and NO and PM have the same length, 8.2. Now, if these lines are parallel, that means they have the same slope. If they are parallel, we have the same slope. If they're perpendicular, they have opposite reciprocal slopes. So, see how this fraction here is 1 over 4? If I flip this over, this would be 4 over 1. And the opposite reciprocal is -4 over 1. So, what that means is there is a right angle here. There's also another one right here, and right here, and right here. I also found that this side here and here are the same in length, as are these two here and here. And then finally, we got a set of parallel lines. Quite a lot of information. Now, number 5. What do the slopes tell you about the lengths in this quadrilateral? Our opposite sides are congruent and parallel, which makes it a parallelogram. So, if it's a parallelogram, there's a couple of different ones it could be. It could be a rhombus, it could be a rectangle, it could be a square. But let's be clear. A square has four equal sides, and so does a rhombus. Are all four of these equal? Uh-uh. So, these slopes are opposite reciprocals, making this four right angles, and because these sides are not all congruent, this makes this a rectangle. Therefore, these slopes and side lengths indicate that MNOP is a rectangle. Quite a bit of work, but we are able to do this. Let's get into this practice. All right, next thing they're asking us to go through to do, they give us a set of shapes, and they want us to go through and find some things to help us out. So, first thing they're giving us is a rhombus ABCD. They're giving us 2 points, and they want us to find the slope of this side. Then they're going to give me a parallelogram ABCD with these 2 points and to find that same slope of that other side. Then they're going to want us to go through and do a couple of things. They give us this quadrilateral ABCD and they want us to find the perimeter. Perimeter is the total distance around the shape added together. So that means we're going to have to be hitting the distance formula. And then given square ABCD with these points, they want us to use the fact that this is a square to find that last location. Go ahead and give it a pause and see that you can try this. If you can't figure it out, it's okay. We're learning it, so let's go through and take a chance. Alrighty, people. Hopefully you're able to go through and try some of this out. Let's do some explanations. First off, on this shape, AB and CD, if you were to actually draw this out to decide, a rhombus has four congruent sides and two parallel sides. Now, this doesn't have to be, super duper exact here. I don't have a ruler on this, but we can see some things. This goes from A over to B, over to C, and then over to D. I get that just by looking at the name. So, if we know this is a rhombus, all four of the sides are the same, that's fine. And we know that this is a parallelogram, so that means that the opposite sides here are parallel. So all we need is to find the slope here for AB, and then we will have the same slope down here for CD. Let's see what it is. AB and CD, they're opposite sides, so their slope are the same. So the slope from A to B, we were going up 4 and over 3. So that means that our slope for the other side will also be up 4 and over 3. 4 over 3. All right, next one we got, they gave us quadrilateral ABCD. Let's graph this thing, and then let's find the perimeter. When I find the perimeter, that means I have to do the distance formula for all this. So remember what that distance formula is. You can either hop to the Pythagorean theorem like we did back in trig, or we can go through and use our calculator. Let's show you what we should have gotten. These right here, 5.1, 5.1, 8.1, 8.1, those are all of our sides. If you want more of an example of how to do this, let's go through and show you at least with two of the sides. If I wanted to do from A to B, I'll look at the points that they gave me here. Our change in our x values was 0 to 1, so that is 1. Plus my change in my y values, 0 to 5, that's 5. 1 squared is 1, 5 squared is 25, which gives me the square root of 26. Now, 26 isn't a perfect square, so that means that this would give us around 5.1 if we had to round this up. So this is exactly what we're doing when we're finding these distances. We just had to go through and calculate that change. So when we add all these up, we end up getting a total perimeter of 26.4. Nice and easy. All right, next one, they want us to go through and find the slope of this parallelogram with slope CD by looking at these for AB. So our slope for any line is our change in y's. So what's our change in our y values? We got from negative 8 to negative 10. So did I go up or did I go down? I went down 2. So that's a negative 2 on our slope. And then how much did I change? I went from negative 5 to negative 3. That is going up 2. Now negative 2 over 2, remember you could reduce that. That is just negative 1 over 1. Which means that since those are the opposite sides, once again, that should be our slope. All right, last one we got here. We're going through it. We're finding where D is if this is a square. So let's look at our points. Here's A, here's B, here's C. Now, in order for me to go through and find D, let's go through and observe some stuff. D has to be somewhere down here, and these guys have to have the same movements to make this 4 congruent sides. So that means that just like how I move here, I got 1, 2, I went up 2, and I went over 1, 2, 3, 4, 5, 6. So I went over 6, and I went up 2. So from here, if I go up 2 and over 1, 2, 3, 4, 5, 6, that should be right around where D is, making this bad boy a square. And that, once again, there's the point. All right, last one that we got here. We're trying to go through and classify this just like we did at the beginning of our notes. So go through and take a look back at that if you are unsure. First step, let's graph our points. Next step, let's name our sides. Third step, let's calculate some slopes. PE, ER, RL, and LP. Those are our slopes here. We got negative 1 over 4. I got negative 4 over 1. I got negative 1 over 4. I got negative 4 over 1. Now, let's calculate our lengths. When I go through and did the distance formula around the shape, I ended up getting 4.1 for all the sides. So what does this tell me? The slope and the side lengths indicate that this thing is a rhombus. It has 2 pairs of parallel sides, that from PE and RL and ER with LP. And all 4 of the sides are congruent. People, we made it. We are out of here. I hope that you were able to have a good day, and hopefully you don't stress out too hard on this. It's been a review, and it's been cool to work with you. See you later.